today we are going to be looking at implicit differentiation, how to differentiate implicit function. Now, we all know that implicit functions are functions, in case you don't know, implicit functions are functions whose subjects is not completely defined. Yeah, the variable and the subjects are expressed together. And if you want to differentiate it, we have two major ways of resolving the issue by finding the derivative. The first method is by using implicit differentiation. The second method is by using partial derivative or differentiation. And the first thing I'm going to do for me now is to subscribe to this channel and ensure you turn up our notification bell, and as well as don't skip any part of this video. If you want to get the full details about this class. So let's go to this. We already have question 1, question 2, and we'll have question 3 here, and we will resolve everything in using two different methods. So the method you like, you can pick it and follow. So the first method I'm going to apply for this first question is the method of implicit differentiation. So how do we do this? First thing is to know the question. We are asking for the y over the x, in which y squared plus x squared plus 4 is equal to 0. That's the question. So what do you do here? The first thing is to differentiate each terms there with respect to x. We're going to differentiate y with respect to x, differentiate x with respect to x, differentiate 4 with respect to x, differentiate 0 with respect to x. Then after that, we'll be having the y over the x inside our derivative. Then we'll make the y over the x formula. That will be the final answer. So, but one thing you should note is that everything there are a form of polynomial function in which we have a variable carrying a constant power. That's a form of polynomial function. And if you are differentiating a polynomial function, what you have to do is to just apply the rules of differentiating a polynomial function. If you know you don't do that, you can also search for our video, go to our channel. It is the derivation of polynomial function. We have done that. So, but if you differentiate y with respect to x, it's supposed to be a constant since there's no x there, but it is not absolutely a constant since y is still part of our variable there. Yeah. So look at, we are looking for dy over, that is the derivation of our respect to x. So y will still be active since we have dy. But the x is what we are differentiating respect to. So that will go to take into place when we are taking derivative. But if you differentiate y with respect to x in terms of this dy over dx, if you differentiate your y, at the end of your answer, you add the y over dx to that place. That will be the final answer to that. Or you from to chain anyway. So what you do is to differentiate. Look at what I've said. Differentiate this. You're going to have 2y from polynomial function. But since you are differentiating y with respect to x in this case, and we are differentiating with respect to x, but you are differentiating this y now, you add dy over dx to the back. If you differentiate y, if you are differentiating with respect to x, but we have the y here, so that's why the y is not a constant number. Then plus 2x, differentiate x squared, we have 2x. Then plus, differentiate 4 is a constant, that's 0. Differentiate 0, I'll give you 0. The next, make dy over the x subject of the formula. We're going to be having 2x, that is 2y, dy over dx. Then is equals to minus, if plus crossing this sign, into minus 2x, then all other things there are 0. The next, divide both sides by 2y, divide the other side by 2y. This will cancel this, then our dy over dx will be equal to 2 cancel 2 minus x over y. That will be your final answer to the problem. So, this is how you do using implicit differentiation. You can also differentiate this or you wish to use this formula we have here. Look at this. This means the over the x, if it is implicit function, the over the x must be equal to negative of the partial differentiation or partial derivative of x in the equation divided by the partial derivative of y in the equation. This means If you are differentiating related to x, all other things, say whether y or any other thing there, should be acting as a constant, partially. Then if you are differentiating related, this one means, this dy means differentiate related to y and take any other thing there as a constant thing. And if you differentiate a constant thing, you're going to have 0. Let's apply this formula and see. dy over ds, according to this formula, will be minus dx, means differentiate everything related to x and take all other terms to be 0. Now, since there's no x here, we have y squared here. So if you differentiate that will be 0. Then plus differentiating x squared, that will be 2x. Then plus 0. And note, if you want to use this formula, the first thing you take regards to is to check whether the equation is equal to 0. If the equation is not equal to 0, ensure you equate everything to 0. It's very important. You now equate everything to 0 before you start your solving. You want to use this formula. Then over dy now means differentiate everything related to y and take all other things as constants. So differentiating y related to y, we have 2y. Then plus differentiating this x related to y, there's no y, then that will be 0 as a constant. Differentiating this 4 related to y, that will be 0 as well. So everything will now be minus 2x over 2y, and that will give us minus x over y. That will be our final answer for that. As simple as this. See, this method is very short. It's actually a shortcut. A very shortcut. Then the next thing is this. Now, we can use this method for this, but a lot of time, if I want to use this method for this, anything you have x, y, you'll be using product rule to solve that. Like this other question, you have x and y. Before you differentiate that, you use product rule. You want to use this implicit differentiation. But if you want to use this partial derivative method, what you do is just to look for the y over dx equal to minus dx over dy. And that will be, now differentiating everything partially related to x and take any other thing there as a constant. This will be a constant, that is 0. And this other one is s here, s squared. Differentiating s squared will be 2 times 3, that's 6 from polynomial function, x, 2 minus 1, that's 1. Then still leave the y squared. Now, if y is attached to x and you are differentiating related to s, the y will not be 0 since they are together. But if the y is alone and there's no s there at all, that's when the thing will be 0. That's why if you differentiate this other one, that will be 0. Differentiating s, that will be 1. Ensure the equation is always equal to 0. That is very important. The equation must be equal to 0. It's very important. So, differentiating x, that is 1. Differentiate 17, that is 0. Over, for y now, differentiate y is power 3, that's 3y squared from polynomial function, plus, differentiating y squared, that will be y, that is 2 times 3, that is 6, s squared, y, 2 minus 1, that is 1, then plus, differentiating y, now that is 1, minus differentiating x, there is no y there, that is 0, differentiating 17, that is 0. So everything will now be minus 6x, minus 6x y squared minus 1 over 3y squared plus 6x squared y plus 1. So this will be our final answer. So from here to here, there is a solution, and it's just actually it's a shortcut. That is our rule here. So let's look at this last question. For this dy over ds will be minus dx over dy. Now, further differentiating everything related to x, this now must ensure the first thing that you move everything to 0. So that's what we are going to do now. That's y power 4 plus 6x y cubed plus y plus 7x minus 27 is equal to 0. Must ensure everything equals 0. Because this one is plus 27. Any number that have sign, so it to be plus. To move this to this side, it becomes minus. Everything must be equal to 0. For that's okay. dy over dx will now be minus dx. Rejecting this one, that is 0, there's no s there. Rejecting this s, that is 1. 1 times 6y cubed, 6y cubed. Rejecting this y, there's no s there, 0. Rejecting 7s, that will be 7. Rejecting 27, that is 0. Over, rejecting this related to y, that is 4y cubed. Plus rejecting this related to y, 3 times 6, 18. X, then 3 minus 1, that is 2. Plus the rating y, that's 1. Plus the rating 7s, that's 0. There's no y there. Related to the 7 by 0, there's no y there. So the final answer will now be minus 6y cubed plus 7 all over 4y cubed plus 18xy squared plus 1. That would be the final answer to that. So here's our rule here, and you can try this in a form. If y cubed plus 4sy plus s cubed is equals to y minus 22, find the y over dx. So for this, the y over dx will be not be far from we are going to have 4y plus 3s squared over 3y squared plus 4x minus 1. So that's what we're going to have in this piece. So try and see if we can do it to get the final answer. So here's our rule here, and please ensure you share this video to others and subscribe to this channel. It's a very important channel and it's highly educative. So God bless you. I'll see you guys in our next class.